All right, we're going to continue our exploration of various properties of real numbers. In today's lesson, we'll focus on the absolute value of numbers. All right, so what is the absolute value of a number? All right, so we're going to frame this around a very simple definition, which is we're going to think of the absolute value of a number as its distance from zero. All right, so when we look at a number line, okay, and if I have, and so let's look at this symbol first. So we have these bars that signifies absolute value. All right, so anytime we see a number inside the bar, like so, all right, it's telling us that we're looking for the absolute value of a number. All right, so now if I put 3 on a number line, so here is 3, and then we want to know how far is 3 from 0. It is 3 units to the right, but it's still 3 units. Notice if I put negative 3 on the number line, let me do this in a different color just so we can see. How far is negative 3 from 0? It is also 3 units away. All right, it's just in the opposite direction. Now, what's nice about this is that this is really a distance, and we think of distances as being positive numbers. So, for example, if you're driving on the highway, all right, if I leave Denver and drive east, I can drive 200 miles. But if I drive west, it's not negative 200 miles, it's still just 200 miles. All right, so when we think about absolute value, the result will always be a positive number because it's asking how far is it? Not necessarily in what direction, but just how far is it from 0. All right, so let's look at another quick example here. So when we look at this guy, all right, the absolute value of 8 is 8. Well, once again, if I put 8 on the number line here, and then how far do we have to go to get to 8? We have to go 8 units to the right. Now, same thing. If I put negative 8 on the number line, hopefully this neon color doesn't hurt your eyes. All right, how far to the left do I have to go? I still have to walk 8 units. It's just to the left. But the distance between 8 and negative 8 to 0 is exactly the same. All right. Now, let's go to, whoops, wrong button here. Let's do this one. All right, so let me do the first one with you just so you can see this. Now, once again, so all we want to do is when we do this problem, it's just really a very simple, quick answer. So if I have to recognize the bars, this means absolute value. So this is basically saying, how far is negative 5 from 0? And your answer would just be 5. It's 5 units. We don't care whether it's to the right or the left. It's just 5 units. All right, so what I'd like you to do now is go ahead and pause, all right, the video, and then go ahead and do these next 4 real quick, and then turn this back on and we'll see how you do. All right, so let's see how you did. All right, so once again, I see my bars here. That means absolute value. So how far is 10 from 0? It is 10 units to the right. All right, see my bars. How far is 1 from 0? It is 1 unit to the right. I have the absolute value of 0. Well, how far is 0 from 0? It's 0 units from 0. We don't go anywhere. All right, and then here, how far is negative 7 from 0? It is 7 units, but just to the left, but still 7 units. So the outcome will always be a positive result. All right, so now let's change the question just a little bit. Now, notice we started with a integer or a number for all of our previous examples. Now we have this variable in here. So the question is changing just a little bit. Instead of asking for the absolute value of a specific number, we're asking what numbers have a specific absolute value. So for this problem, this is saying, okay, we have the absolute value of x is equal to 4. So this is saying what numbers, okay, that's, remember x is an unknown, what numbers are 4 units from 0? All right, so if I go 4 units to the right, I get to 4. If I go 4 units to the left, I get to negative 4. So x could be 4 or negative 4. It could be either one of those. All right. Now, so let me erase this real quick. Gone. All right. Now we move to the next guy. All right. So what numbers, okay, have a distance of 8 from 0? So once again, if we go to the right 8 units, take 8 steps, where do I end up? I end up at positive 8. If I start at 0 and I take 8 steps to the left, I end up at negative 8. So x could be 8 or negative 8. And then finally, let's look at this. This says, once again, we see our value, absolute value bars here. What number okay, because that's x, what number has a distance from 0 of -5 units? So can our distance be negative? And the answer is not in this case. All right, so if I see this question, all right, just like we did in some of our previous lessons, this is going to be a no solution problem for us right now. There are no numbers that have a distance of -5 units. It's either 5 to the right or 5 to the left, but not -5 units. So this will be a no solution problem because once again, we're talking about a distance. All of our distances will be positive. All right, now, there's also another slight variation on this problem. All right, now notice we have a lot of stuff happening inside of our absolute value bars now. So now this number is saying, okay, when I take a number and I subtract 2, its distance from 0 will be 4. All right, so we're still looking for two numbers that have a distance of 4, but I have to subtract first. I have to subtract 2 to get there. Now we're going to use those previous examples to kind of think about this. All right, so let me put this up. So if we had the absolute value of x was 4, all right, we would go 4 to the right, and that would be 4. We would go 4 to the left, and that would be -4. So if it was just the absolute value of x, it would be 4 or -4. But it's not. We have this extra piece in here. So how do we handle that? Well, we're going to be a little bit math savvy. So we know that we have to get to 4 or -4, but we have to subtract 2 first. So let's start with this. Okay, what number do I have to subtract 2 from to get to 4? And the answer is 6. So notice, if I start at 6 and I subtract 2, all right, that's what this means. Take a number and subtract 2. Is its distance from 0 equal to 4? Well, I get to +4. It is. That works. Excellent. So we know one of our answers is 6. Now notice, if I plug this in and see how this works, I get 6 minus 2, which is 4. Oh, the absolute value of 4 is 4. Oh, that really works. So once I get this number, I can go back and substitute it in for my variable to see if it works. All right, now let's think about this. Now we have -4. Okay, so I want to get to here. So what number do I have to subtract 2 from to get to -4? Well, if I start at -2, subtracting 2 means to move to the left 2. All right, just like I did here, subtract 2 here, moves to the left 2, subtract 2, and I get to -4. So my answer here would be -2. Now, once again, if I plug this in, -2 minus 2, -2 minus 2 is -4. Is -4 4 units from 4 or from 0? Absolutely. So you can kind of use what you already know in a simple case, all right, like I did here, and then think about the operation that will get you to those numbers. All right, let's look at one more of these before I have you do some work on your own. All right, so now, once again, we want to take a number, add 3 to it, and take the absolute value that will give us 5. So once again, if we go back to our simple case, the absolute value of x is 5. We know that that would be 5 or -5. So I've got to get to 5, and I have to get to -5. But to do that, I've got to take a number and add 3 or move to the right 3 to get to 5. So now if I go back and look, well, that would be 2, because if I add 3, I get to 5. All right, so yeah, 2 plus 3 is 5. All right, the absolute value of 5 is 5. So there's one possibility. Now what's nice is I can mimic this because I have to find another number where I have to add 3 or move to the right 3 to get to -5. So I can go over here and say, oh, that must be -8. So then if I add 3 to -8, I get to -5. Well, there's my second solution. X can be 2 or x can be -8. All right, so here's what we're going to do. I'm going to give you a couple problems. All right. Oh, do I have one more of these? Oh, well, let's do one more then. I thought I was to your examples, but we'll go ahead and do this one together. All right, so once again, let's look at our simple case here. All right, so the absolute value of x is 7. All right, if this were the case, we know it would be 7 or -7. So I need to get to 7, and I need to get to -7. But I have to do that by adding 2. So I've got to move to the right 2 to get to 7. So So if I go back to 5 and move right 2, that gets me to 7. So my first possibility is 5. And notice if I mimic that here, I have to start here and move 2 to the right. That gets me to negative 7. So then there are my two solutions. And once again, if I plug that in, 5 plus 2 is 7. That works. If I plug that in, I get negative 7 plus 2, which is I'm sorry, this should be negative 9. Whoops. Negative 9 plus 2 is negative 7. The absolute value of negative 7 is, in fact, 7. All right, now, after a little bit of delay, now it's your turn. All right, try these two real quick. All right, turn the video or pause the video and then come back on, and then I'll have two more for you to wrap up today's lesson. All right, let's check out and see how you did. All right, so now notice the question here is asking what numbers are a distance of 7 units from 0. So if I go 7 units to the right, I get to 7. If I go 7 units to the left, I get to negative 7. So x could be 7 or negative 7. All right. Now here it's saying what number has a distance of 10 from 0. And once again, if we go to the right 10, we get to positive 10. And if I go to the left 10, I get to negative 10. So x would equal to 10 or negative 10. All right, now let's try two more. Now once again, this is a little bit more difficult because you got to think about how to get to those numbers. So go ahead and pause the video and try these two, and we'll see how you do. All right, now let's see if you could get these challenge problems. All right, now let's start with the simple case here. Let's look at if it was just the absolute value of x is equal to 2. That means x could be 2 or negative 2. So we need to get to 2. And we need to get to negative 2. But to do that, we have to add 1. That's what this is telling us. Pick a number, add 1, and we have to get to 2 or negative 2. Well, in this case, that means I would have to start at 1. And notice if I add 1, I get to 2. So our first answer could be x is 1. Well, then I'm going to mimic that here. To add 1 to get to negative 2, I would start at negative 3, and I would move to the right 1. So then those are our two solutions. And once again, I plug that in. 1 plus 1 is 2. All right, that works. Plug that in. Negative 3 plus 1 is negative 2. That works. All right, now this sometimes just makes students uncertain when they see this problem. So let's take a look at how you would have handled this. Now once again, let's look at our simple case. If it were just the absolute value of x equals to 4, we know that that would be 4 or negative 4. So I have to find a way to get to 4, and I have to find a way to get to negative 4. Now the way I do that is it wants me to take a number and then subtract 4. So I've got to move to the left. That's what subtracting 4 means. So if I do that, notice I would have to start at 8, and I would have to move to the left 4 to get there. So my first solution is x equals 8. And notice if I plug that in, 8 minus 4 is 4. Beautiful. But notice if I mimic that here, I have to start at 0 and move to the left 4 to get to negative 4. So my second solution is 0. And sometimes when students get 0 here, they're just a little uncertain because that doesn't happen a lot. But that's a very legitimate answer, a very legitimate possibility when you're working problems. And notice if I plug 0 back in, I get 0 minus 4, which is negative 4. The absolute value of negative 4 is, in fact, 4. All right, so that wraps up, all right, this lesson on absolute values. All right, you're now ready to do worksheet Unit 04. All right, so check that out and let me know if you have questions.